Hello guys, today we are going to learn about rotational of rigid body, and this is part 1. Rotation is defined as the circular movement of a body around an axis. If the movement is around an internal axis that goes through the body's center of mass, like this spin top, that rotational movement is known as spin. It can also move around an external axis or orbit, like the moon orbiting the earth, which causes the moon phase to change. A rigid body is a solid body that has no change in shape or dimension when the force exerted on it. There are few examples of rigid body such as stones, wood beam, and steel beam. So now we can define the rotational of the rigid body as the circular movement of a body around an axis with no change in shape of the body. Rotational kinematics is a description of rotational motion which describes the relationships among angular displacement, angular velocity, angular acceleration, and time. Let us begin by identifying the initial point in which the distance is the radius of the disk. As the disk rotates, this point will change its position in time. The change in position, which measured in length, will give us the arc length. The angle that's swept out by the rotating disk as the point changes its position will be the angular displacement. Angular displacement, or delta theta, is not measured in degrees but rather radians. In parallel with our analysis model of a particle under constant acceleration, we can generate a new analysis model for rotational motion called a rigid body under constant acceleration. Notice that these kinematics expression for the rigid body are the same mathematical form as those under constant acceleration for particle. They can be generated from equation for rotational motion by making substitution linear displacement with angular displacement and other components. Finally, we are going to look at three different acceleration and their direction for a rotating object.